I'm Dr. Dwayne Rieger, and welcome back to GeoMapApp Tours. Today we're going to look at the third and final type of tectonic plate boundary, which is convergent plate boundaries. Now, since there's two types of lithosphere, oceanic and continental lithosphere, there's three different combinations of convergent plate boundaries. You can have oceanic lithosphere converging with continental lithosphere. You can have oceanic lithosphere converging with oceanic lithosphere. And you can have continental lithosphere converging with continental lithosphere. Now, each convergent plate boundary in which oceanic lithosphere is involved, a process known as subduction occurs, where oceanic lithosphere subducts down into the mantle along the convergent plate boundary. We're going to look at a first type of convergent plate boundary, which involves oceanic and continental lithosphere. And so we have subduction. Let's zoom in to the west coast of South America. Now, each subduction zone has several features. First, we have what we call the deep ocean trench, this dark blue line running along here. So in this case, the Nazca plate subducts under the South American plate. The overriding plate, which is the South American plate, gets flexed down slightly where this Nazca plate is subducting underneath it, forming this trench. So deep ocean trenches run along subduction zones. And also, subduction zones exhibit large earthquakes and volcanism. So if we plot our volcanoes and earthquakes, and most of the volcanoes are covered up by the earthquakes, but volcanoes run along the spine of the west coast of South America. You see some of them down here. We also have many earthquakes, and some of the largest earthquakes to have occurred as you go further away from the trench, and this is because the earthquakes continue to occur in the subducting lithosphere of the Nazca plate as it subducts down into the mantle. We can view this a different way if we leave GeoMapApp for a second and go to the Iris Earthquake browser. This is a segment of the South American subduction zone where the Nazca plate is subducting the South American plate. We can see the earthquakes mapped here, color-coded. Look at this, 3 dimensions. We can see here this is north, this is south, west, and east. So we're looking at map view. Here is the coast of South America, and this is the trench. Now if we rotate our view, so now that we're looking at the cross section, we can see that those earthquakes form a structure, and that is the descending oceanic lithosphere of the Nazca plate, subducting under the South American plate. It's pretty cool, isn't it? So we're able to visualize these subducting slabs of lithosphere by mapping the locations of earthquakes. A feature that's associated with oceanic continental subduction is the presence of coastal mountain ranges. So the deformation of the continental crust due to the convergence forms a mountain range along the coast. In this case, we call these the Andes Mountains. Okay, so each subduction zone has a deep ocean trench, large earthquakes, and volcanism, and oceanic continental subduction results in coastal mountain ranges such as the Andes. Next, we're going to look at oceanic subduction. So here we're going to zoom in to the Western Pacific Ocean. Okay. And so we can see that there's subduction in here because we can see the trenches. Right? See these deep ocean trenches, these dark blue lines. Okay. And where you have oceanic subduction, the volcanoes, which always form on the overriding plate, they don't occur on the continent. They form on the sea floor and grow in size until they eventually reach sea level and form volcanic islands. So you have chains of volcanic islands We call these volcanic island arcs because, as you can see, subduction zones usually are in the shape of an arc, and so the volcanic islands following the subduction zone are also in an arc, letting your name volcanic island arc. So, for example, the Aleutian Islands, the Japanese Islands, the Philippines, the Marianas Islands, these are all volcanic island arcs associated with subduction zones. So we have the deep ocean trenches with the volcanism, in this case the volcanic island arcs. We have large earthquakes. Some of you may have remembered the 2011 Tohoku earthquake that occurred off the coast of Japan. That was one of these subduction zone earthquakes that generated the tsunami. So if we plot the locations of earthquakes and volcanoes, once again most of the volcanoes are covered up by the earthquakes. You can see some of them in here, but you can see how the depth of the earthquake increases as you go away from the trench towards the overriding plate. In this case, it's the Pacific plate subducting underneath the Eurasian plate. Sorry, the North American plate, actually. Here. Okay. And the deep ocean trench associated here with the Marianas subduction zone is actually the deepest point in the ocean. It's just under 7 miles deep, the Marianas Trench. And so, new oceanic lithosphere is created at divergent plate boundaries along the seafloor, mid-ocean ridges. And here, at convergent plate boundaries, oceanic lithosphere is destroyed. And finally, we're going to look at our third type of convergent plate boundary. That's continental. And a good example of that is the Himalayan mountains, which are formed by continental convergence from India, the subcontinent of India, colliding with the Eurasian plate. So this convergence forms very large interior mountains. You can see this deformation front. This is where the Indian continent is converging with the Eurasian plate. India is sliding underneath, the continental lithosphere is sliding underneath, but continental lithosphere is too buoyant to subduct or sink into the mantle, so it just slides underneath and it pushes up the continental lithosphere of the Eurasian plate, forming this plateau. You can see how this deformation front extends all the way around the Indian subcontinent as it collides into Eurasia. The largest mountains on the planet are formed by continental convergent plate boundaries. And if we look at the locations of earthquakes and volcanoes, so there are no volcanoes along continental convergent plate boundaries, but there are many earthquakes as rock is compressed and fractured and faulted. Okay. And finally, we have one more example of a continental convergence on a slightly smaller scale, and that is the Alps. So the Alps are being formed by the convergence of the Italian peninsula with southern Europe. So that convergence is forming the Alps. If we map earthquakes, we see some earthquakes. There is actually some subduction along the Italian peninsula, and over here, and that's what actually created the Italian peninsula, and that's where the volcanoes such as Mount Vesuvius, Mount Etna, Stromboli, and so forth are a product of, is that subduction. So that's been our tour of convergent plate boundaries. Thank you very much for joining us, and I hope to see you next time.